So from previous sessions, we learned about all the solid principles like single responsibility principle, open close principle, and list queue substitution principle, interface segregation principle, and dependency inversion principle. So today's session will build a project which actually includes all the principles. That is what we will do today with hands-on. Basically, this topic we will try to cover. Okay, so I have already opened our project. Uh, so what I will do is write a project in which I will create a file called main.go. So we already did earlier some hands-on with single responsibility principle. Single responsibility principle is nothing but only which should have only one region actually or single responsibility. So what we will do as part of this project is we will try to implement a authentication service with multiple options like authenticate using password, authenticate using fingerprint, and so on. We'll use this entire project to cover all the solid principles. That is the main goal of this thing. So for now, actually, for start with uh, this project, we'll try to implement a single responsibility principle. We'll construct like a user repository, and also we'll try to implement a authentication service. We will try to implement authenticating user and get user by username, so on things, and then we will verify this by implementing the SRP. Next step is we'll extend the same project by including or implementing the open close principle. How we can enhance the same project by using the open close principle. Similarly, for next step is we will try to implement Lixus substitution principle by adding some other functionality to the existing project, and also we'll try to implement the interface aggregation principle by adding new interfaces to the existing code, and then we'll try to expose the client specific interfaces. At the end again, we'll try to implement or decouple from the high level component, low level component by implementing the dependency inversion principle. So this is what we'll cover as part of this session or this project, Golang project with the hands-on. Fine. Let's see like what we can do now by single responsibility principle. So what I will do is package main. So as I told, like we'll try to construct a user struct represents the user in the system. Okay, so this is actually type user struct. For now we will use two words only, two things. One is username, which will be string, and second one is password, which is also a string, right? So once we are done with this, we'll try to create this is a single responsibility, handle the management operations active user repository. User repository actually handles user management operations. Okay, this one also struck user repository of a struck which will has array of users. Okay, perfect. So now what we will do, we will create a new user repository tree to initialize a new user. Okay. What is this? Quick slash new slash repository. So this is basically function. Okay. New user repository and which will return user repository. Okay. But basically what we will do here is return address of repository users make array of, this is actually slice of length 0. Okay. Okay. So we are done with this new method as well. Now what we will do is we'll try to implement methods, one method for add user. Okay. Add user adds a new user to the repository. Okay. So what we can do is func user repository add user of user, right? And this will do nothing actually. User just try to add users. It will try to append users by user. That's it. Okay. So this is actually, if you observe that all having single responsibility only. Okay. So now we will try to add authentication service. Authentication service handles user authentication operations. Okay, this is again type abstract authentication service struct. So which will have a user repository basically of type user repository. Okay, so we'll make again one method which actually creates new authentication service method and slash a new authentication, say authentication service. Okay, so the func new authentication service which will take user repository of user repository and this will return authentication service. Okay, and you have to return authentication service. Oops. Authentication service of user repository of user repository. Okay, so we are just making everything as a single responsibility for everything. Now what we will do here is we'll write two functions implementation. One is authenticate user. So what we will do is authentication authenticate user authenticate a user based on provided credentials. Okay, now what we will do is func of authentication service, authenticate user. Here actually what we will take is username, password of type string. Now what we will do is we'll return boolean error. Okay. Now what we will do is we'll try to get uh, user and error from as dot with the private method user by username. We'll take username as a input. Okay. So if error is not equal to nil, then there is error. Just return false comma error. Otherwise, return user dot password equal to password. Right. Now what we will do? We need to implement one more function called get user by username retrieves 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 a user from the repository from the tree by username. Okay. So now what we will do is func authentication service authentication service get user by name username of type string return bool comma sorry we will return user actually user comma error. Okay. So here what we will do is what is the problem here? Oh, okay. True comma nil, right? Okay, fine. So here what we will do is get user by username. So what we will do here is for user equal to range of s dot user repository users, right? If user dot username equal to username return user comma nil. Otherwise return user empty errors dot new. We'll give simple message here user not found. Okay. Okay, basically this single responsibility principle we have covered everything here because everything has a single responsibility. This already we discussed in previous class or previous session. Let us test this one using main function. I will try to create a new user repository. Okay, how you can do that? You can use user repository equal to new user repository. We're calling that function. It will return it. Now what we will do is we'll create a user. Okay, user of, okay, username. I will give my name only, and password will be like secure secure password. We'll try to add so what we will do is we'll add user repository dot add user of user, right? We're adding this user to this. Okay, now what we will do is once this is done, we'll try to create create a new authentication service with the user repository, whatever we created now. Okay, auth service equal to new service of user repository, right? Now we'll try to verify by creating local variables username equal to Shiva and maybe you can create here only password is secure password, right? So once this is done, we'll try to check this one is authenticated. Authenticated, what we'll do is auth service we can use dot authenticate user by passing username comma password, right? Now let us check this is authenticated correctly or not. We have first we'll check error should be nil. If error is not equal to nil, just uh, println authentication failed. Authentication failed, and we'll try to print what is error dot error. Okay, and with nothing to proceed now, we can return from here only, right? Once this is done, then what we'll do, we'll check if is authenticated is true, fmt dot println authentication successful. Successful, we can welcome the user, right? Username. Otherwise, what we can do is we can do it dot println authentication failed, invalid invalid credentials. Okay, so this is the end-to-end single responsibility principle. Let us test this code once and see what happens. Okay, go run main. Okay, so this is authentication successful and we are good with the single responsibility principle. Okay, So what we will do for the extending this with the open close principle now. So we'll try to introduce the authenticator, okay, authenticator interface to define the contract for different authentication methods. So for now, what we will do is the password authenticator is an implementation of authenticator interface handling password based authentication. So the authentication service now supports multiple authenticators, allowing us to add new authentication method without modifying the existing code. Okay. So now this extension aligns with the open close principle as authentication service is open for extension. That means we can add new authentication methods, but closed for the modification. Okay. So this we will do now. How we will do that? We'll try to, as I mentioned, we will try to add the authenticator. Okay. Authenticator interface. So where we will add here, there is authentication service. We already handled this here. So to make the open close principle here, to extend the same code here, so what I will do is I will introduce the interface called authenticator. Okay, defines the interface for different authentication methods. Okay, we'll see that how we can do. So this is interface. Please try to understand this authenticator of type interface, right? So this authentication interface basically has a method called authenticate, which will take authenticate. It will take actually user of user and password of type string. Okay, this will be returning boolean variable with a success or failure. Okay. So now what I will do, what we'll try to do is we'll try to implement this authenticator with the password authenticator. Okay, that is this password authenticator is an implementation for implementation of authenticator for password based authentication. Okay, so type password authenticator. This is basically struct. Okay, this one actually try to implement. Okay, authenticate authenticates a user based on a password. Okay, so what we will do here is we'll try to func password authenticator password authenticate. It will take user of user and password of type string. It will return boolean variable, right? That's what we implemented. Okay, so now what we will do is we'll simply return user dot password equal to password, whatever password we have received, right? Okay, so this is actually the interface where we are extending, and So the authentication service actually currently what we have here is user repository, right? In addition to this, what we need to have is we need to have a authenticators, authenticators, which are actually authenticator, array of authenticator. So currently we are supporting for the password kind of authentication. Tomorrow we want to finger print authenticator. We can keep improving this basically, right? So since we added this one, so the new service creation will changes. Okay. So basically what happens? So what we do authenticators. So here what we can do make authenticator 0, right? So we are done with this. Now what changes we can do is, okay, now mm, mm, mm. So we need to extend this authentication service with new thing we need to add here. Basically what we can add is, because we introduced something new called authenticators, we'll write one more method here, add authenticator, add authenticator adds a new authenticator to the authentication service. Basically we are extending this func authentication service, add authenticator, and authenticator of type authenticator, right? Now is dot authenticators equal to append authenticators of authenticator. That's it. So basically we are extending this, right? And so once this is done, actually this authenticate user, authenticate user, we have already that, right? We have already this, but what we need to do is we need to make the things in little different, because this is no more required for us. Let me tell you why. Because you are not we no need to read uh, any user. Actually we authenticator will take care about this thing, authenticate user. Okay, authenticate user method will take now two parameters of different, one is user and password, right? So we already got the uh, password and all, but we can keep that one also, but just I want to make sure like you utilize the uh, here we no need of this getting and all. Okay, so we just return, I'll relieve this thing. We have user already, no need to get for user separately. But here what we can do is authenticator equal to range of as dot authenticators. Oops. Just a minute. What we are doing here is this one actually. Range of as dot authenticators, right? Oh, this is the wrong. It is showing range of authenticators, authenticate service. Right, range of authenticator service. What we can do is if authenticator dot authenticate user comma password. If this is succeed, return true comma nil. Okay. Basically, error also not required here. I will just return either succeeded or not. Password. Oh man, CSSW already. Or, okay. I think this is also not required. Return true. Otherwise, just return false. Okay. So basically, we are extending this with uh, by introducing the uh, interface for authenticate and authenticate completely. We changed these things actually by extending it. This for the password authenticator, right? Perfect. Now let us see uh, how we can handle this in the password authenticator. Okay. So we already created this one, right? Username and this thing, right? And we recreated the repository also. So we added a user as well. I don't want this one now. And also we don't want much complication because we removed error things and all. I will remove this also. I will remove this one. Authenticate user. This basically takes user, and we can take secure password. Okay. Okay. So now, yeah, we can user dot oops username. I think this should be fine, and we are able to cover the open close principle here, open for extension and closure for modification principle implementation. Let me run this code and see what we will get. Go and main.go. Yeah, invalid it is saying. Why? Okay, user is user Shiva. Why this is not comparable? Let me run once again. Invalid. Yeah, let us see like user password authenticate user authenticate user authenticate. This is authenticate. We are passing password user password. Mhm. Let me run user dot password. Let me see this one. What happens? Hmm. Okay. Okay. Let me see what is happening here. Yeah, service dot authenticate user. Service. This is now service. Hmm. Oh, okay. Got it. Got it. Okay. So what we need to do is a service, our service we have created this, and also we need to our service dot add add authenticator, right? Here we need to add, sorry, password authenticator. Perfect. So now it should work, right? Clue. Let me pass the password from my local secure underscore password. Perfect. So now we covered single responsibility principle and also open close principle as part of uh, these modifications. Now let us introduce the list queue substitution principle for the existing code, same code basically. So for that, what we can do is we can introduce a new authenticator called fingerprint authenticator that implement authenticator actually. And now the authentication service can use both password authenticator and the fingerprint authenticator both actually. So this extension no actually s- so involves like a list queue substitution principle, so that the different authenticators subtypes can be used interchangeably with the authentication service without any breaking the authentication logic. So that is what we can do now. Yeah, let us see like how we can do that. Okay, so now uh, the first thing is actually what we will do is we'll try to, so the authenticator, whatever the interface we have, so we are passing like here like a password directly, but what we will do here is we'll pass the credentials. That change we will do now. This is just for more readability purpose. Okay, fingerprint actually comes with the different options, not password, right? It comes with some data, binary data. So that's the reason actually I just want to change this one. And this one also, this authentication we have already existing things, right? We already use this one. This also will change it. And so once we pass this one here, we'll try to get the conversion, because you need to convert password comma okay equal to credentials dot string. uh, uh, String, we are just typecasting this. Okay, uh, suppose this is not if not okay, we will just return false, right? Otherwise same thing, nothing changes, because we want credentials for uh, the the fingerprint related stuff. That's why we use it like this for existing little modification in the existing code. So now what we will do now is we'll try to introduce new thing called fingerprint authenticator. Okay, is an implementation of authenticator for fingerprint based authentication. Okay, so this is for fingerprint. What we can do is authenticator of type struct, right? Okay, so now we'll implement the method authenticator authenticates a user based on fingerprint. So func FA star fingerprint authenticator authenticate. It will take user and uh, credentials of interface, right? Okay, interface array. And as usual, this will be returning boolean. Okay. So now what we will do here is we'll try to uh, we will see like what exactly the credentials for this user with fingerprint and all. That's okay. For now, what we can do is we'll try to return the true. This is just for understanding. Like we are just trying to extend this to the other kind of authenticator, and this will be replaceable with the whatever authenticator we have created interface. This is actually that is what we need to achieve the for now. Okay. Okay. Now one more change we need because we changed the so authentication service, right? Authentication service. This authenticator will come. This authenticate user also now not taking this one. It will take credentials of interface type, right? So now this will authenticate will take credentials only directly. This small modification we need to do. Hmm, one that is done. Once that is done, what we will do is we will try to add. We already added a password authenticator, and also we'll add the here, right? We already added here password mm, password based authenticator. We added here, and we'll try to add other one is the fingerprint based authenticator. Okay. Okay. What we'll do is we will add auth service dot add authenticator of type fingerprint thing. Okay. So once we're done with this, okay, fingerprint authenticator. Now, so we already done this authenticator thing like by passing the password. So now what we'll do is we'll try to we'll try to we will try to do that authenticate is authenticated password based. Fine, right? We'll see one more thing here. Once we are good with this, I will try to call here is authenticated via fingerprint. That is equal to what we will do is here password authentication successful and password authentication failed. Now here what I will do is auth service dot auth service dot okay, okay. Okay, what we can do here is, yeah, authenticate user by passing user, comma, we can pass fingerprint underscore data for now. So now what we will do is we'll try to do same thing here also, but for fingerprint. So we are trying to implement extend the things for the two kinds of authentications, like a password authenticator, and also we're extended with the fingerprint stuff. Let us run this and see what happens. Yeah. So this is the thing actually we are able to make the things to extend the. Actually, we are able to replace the authenticator service with the concrete things like a password authenticator or fingerprint authenticator, right? So the same thing actually what we will do is we'll try to introduce the support for interface segregation principle here itself. Okay. So to make that happen, so what we will do here is, so we will introduce the next thing is a user manager and authentication manager, right? So we have currently we have user and authenticator, right? So what we will do is we'll two new interfaces will separate the responsibilities of user management and authentication management by introducing user manager and authentication manager. So user repository will be implements the user manager and authentication service will implement the authentication manager now. Okay. And this segregation allows clients no depends only on interfaces, uh, whatever they want to use, so that whatever they don't want to use they can't touch that actually. So that is how you can separate it by adding the new interfaces, so by introducing new interfaces like user manager and authentication manager. Okay, let us see that how we can do that. Okay, so to make this to happen, what we will do is we will, as I told, we'll try to introduce the two uh, managers, user manager and authentication manager. uh, what we'll do is, as I told, okay, authenticator, and we'll see here fingerprint after fingerprint and before authentication service. We'll try to introduce the user manager, right? User manager actually defines the interface for user management operations. Okay, so type user manager of type interface. Okay, so this one actually had user, which actually takes user of type user. That's it. And as I told, we'll introduce one more thing called authenticate authentication manager defines the interface for authentication operations. Okay, type authentication manager of type interface, which will have two things actually. One is add authenticator. Okay, add authenticator of type authenticator authenticator of type authenticator. This is one. And second one, what it will have is authenticate user. Authen- Authenticate user, which will take user, user and credentials of type interface, and it will return boolean variable, right? So we are trying to separate the things as per the client need. Okay. Okay. Now, so what we can do here is let me take. Okay. So now, so we have done the implementation of introducing the uh, new interfaces for user manager and authentication manager, right? So from the main function, what I want to do is I want to add I want to create a let me run this code will run or not first thing. Go run main.go. Yeah, this is working as expected. So now what we can do is we will try to use the user manager. So what we'll just verify that user repository whatever we created, user repository. Okay, and we can try to add user manager dot add user. We'll try to add one more user here. Oops. Um, user username is Prasad, and password could be another secure password. Okay, and we'll try to see this. We'll try to what we'll try to do is we'll try to authenticate this user. Oops. We'll try to authenticate this user now. User one. Okay, user one. Okay, let us try this one. Let us see this guy will authenticate or not after separating the things. Okay, this is not required now, and I can use this password here. User one, user one. Okay, let us run this code and check our interfaces whatever we created are yeah. So all good now, right? Perfect. That means we are able to add the user using user manager interface successfully. Okay. So this is basically we covered single responsibility principle, open close principle, excuse substitution principle, and interface segregation principle as well. And the last one is dependency inversion principle. So for that, what we will do here is we'll try to modify the things by introducing the user repository interface to define the contact for user management operations. And also we'll see in memory user repository, implement the user repository interface for user management and in memory storage. So the authentication service now depends on the user repository interface. Okay. So dependency, uh, it will indirectly it will start, following the dependency inversion principle. Clients can inject any implementation of user repository, flexibility of decoupling high level and low level modules. Okay. So this is actually easy substitution for the implementation of user repository without modifying the authentication service. Okay. Okay. Let's do this. I think with the hands-on, you will get some idea like what exactly we are trying to do. Okay. So as I mentioned, we will make the user repository interface. Okay. And also we'll introduce in-memory things. Okay. Let us do that. Mm-mm. Okay. So one minute. Okay. So we can do one thing here is user repository. Okay, user repository will be now interface, and which will have add user, user. Okay. And one more thing what we will introduce is, okay, earlier it was okay, this is the interface now, and this is actually we will introduce one more thing called in memory user repository. Okay. In-memory user repository, which actually initializes a new. Okay, basically what I want to do is I want to create a user repository interface we created. Okay, in-memory repository actually what we need to do is should handle the user management operations. Okay, this one actually what it will do, you type in-memory repository of type struct. Here actually what we can do is you can do users of type user array of users. Okay, perfect. Now this new user repository we can make it as a new in memory in memory repository. This will return. Okay, this one will be again in memory repository. That's it. We are just trying to alter the existing things, and also this will be same as that user memory in memory, and we can add user. Okay. Now what we can do is authentication service basically will take user repository and authentication repository. That's correct. Now in main function, if you come here, we'll try to create uh, new in memory repository. Okay, this is user repository as usual, and here authentication service. What it will take is okay. This one new authentication service. Let me see what it will take. New authentication service. New authentication service will take this one. Okay, now I think it should go off now. Okay, now I think that's it. We are actually trying to decouple the things by introducing new stuff. Go run main.go. Let me see what happens. Yes, that's it. So basically, in the dependency inversion principle, we introduced a new interface called user repository. That is this one. We converted into interface, and also we introduced a new thing called in-memory user repository, which implements the user repository. This one, and also authentications are now depend on the user repository interface. Okay, earlier it was a structure, now it is in the interface. That means we're completely decoupling the things and no high level and low level components. I think that's all about everything about covering each piece basically as a project, and this is how you can utilize object oriented way in Golang to adopt the solid principles. Okay, so now let me refactor entire code. Here user.go package main. Okay, now package is done. Now user repository. I'll try to take this one alone. User underscore repository dot go package main. Okay, now I will take in memory stuff into one thing. Okay, uh, memory go package main. Okay, now we can take authenticator as a separate one. Authenticator twitter.go case main. After this one we can go and password authenticator is separate one. Password h authenticator.go, and another one is fingerprint authenticator. Okay, fingerprint authenticator.go. Okay, after fingerprint authentication go, you can pick the user manager, authentic user manager as separate file, user manager.go, package main. After that, authenticate manager, authenticate manager.go, package main. Now what we will do is we'll try to move the authentication service stuff to other file, authentication service.go, package main. Okay, now come back to here. Okay, now I think all got saved now. Now let me go to terminal and then try to cd project clear, go build. You observe there is a project.exe is created. Now let us run project.exe. All good. So this is the overall uh, project related to covering all the solid principles, that are single responsibility principle, open close principle, list view substitution principle, interface segregation principle, and final one is dependency inversion principle. Thank you.